To mathsonlinetuition.com videos, episode 28. We are beginning C3 chapter 1, Algebraic Fractions. Again, with the beginning of every module, we always start easy. We introduce some of the new ideas that are later going to be expounded upon in the rest of the module. And we're going to, in this particular chapter, go over just some simple manipulation of fractions, which will lead us into utilizing long division and the remainder theorem in order to appreciate what a quotient is, what the divisor is, and what are some of the other elements included in that method. So 1.1, you've been asked to simplify these fractions. So the method of doing this is by appreciating the commonality between the numerator and the denominator. You can see for A, we have the factors that are multiplied to result in that particular value. So 16 is 4 multiplied by 4, 4 being the factor of both, 4 being the factor of 16. And then we look for the common factor. The common multiple here is 4 between the numerator and the denominator. We can cancel them out and we can see that we have 4 over 5 left remaining. And likewise for B, you can see that we have, if we factorize both the numerator and denominator, we have x plus 3 in brackets, so we can cancel that out and we will be left with a half. Now C, if you look at first glance, you can appreciate that there is some even numbers and there's an odd number. There's also the x. Those are the different terms and values in the numerator and denominator, but unfortunately there is no overriding common factor between the two. So the fraction stays as it is. It can no longer be simplified further. And here for example 2 and example 3, you have a run through of how to appreciate these examples. We'll do 3 just to warm us up further. So we can see that we have a quadratic here and a quadratic in the denominator. This can be turned into follows using the sum of 2 squares in the numerator, and then just factorization in the denominator. We get x plus 1 in brackets is the common factor between the two. We can cancel them out and we have these two values here. And some exercises for you to do there. 1.2, you multiply fractions together by finding the product of the numerator and dividing by the product of the denominator. So here again, this is GCSE, probably pre-GCSE even, how to multiply fractions together. It's not very difficult. As you can see, all we have to do is multiply the products of 2 and 5 for the denominator and 1 and 3 for the numerator. And this is a good example in question, an example for part B, to show you how to do it regardless of what the numbers are. A, C, B, D represent variables. Example 5, once again, just asking you to simplify, just to focus on part B. Now it's asked you A over B multiplied by C over A. You can see that the A's are cancelled, so you get CB. Now whenever you have, again, the same number on the numerator and denominator, they cancel out and they give you 1 in their place. And again for C, where we have some quadratic, linear and just individual terms, individual variable numbers, you can see that we've multiplied the top and the bottom. Okay, and then we can see there is commonality in the x plus 1, so those have cancelled out, and then we've left with the terms to summarize. So to divide by a fraction, multiply by the reciprocal of that fraction. What does that mean? So this is the age-old rule, which is if you have A over B divided by c over d. This is also equal to a over b multiplied by d over c. So this is the reciprocal of, this is the reciprocal of that. And we've also changed this. So let's use a good example that they've provided us with here. If we divide 5 over 6 by 1 over 3. So this is going to be equal to 5 over 6 multiplied by 3 over 1. So what do we have? You can see that we can simplify 3, which gives 1 and 6, which gives us 2. And then we can see that 5 multiplied by 1 and 2 multiplied by 1 gives us 5 over 2. Okay? And a good raw example is shown here, where we have a over b divided by a over c, which gives us a over b multiplied by c over a. This is cancelled, this is cancelled. Gives us 1, 1 in its place. Have 1 times c, b times 1. Again, that's just going to give, that's going to be the identity, so we get c and b, c over b. And you have some more involved questions here, and these are exercises for you to do. Now 1.3, you need to have the same denominator when you add or subtract numeric or algebraic fractions. And again, this goes back to pre-GCSE, just how to resolve a fraction. So 1 over 3 plus 3 over 4. So we need to find the common a multiple between the two. So we multiply the denominators to give us 12, and as we have manipulated the bottom, we also reciprocate the same on top. So we had 3, now we have 12, so that means that 3 has been multiplied by 4, so now we multiply 1 by 4, and where we had 4 we now have 12, so 4 has been multiplied by 3, so we do the same on the numerator, so we get 4 plus 9, and then you can see we have 13 over 12, okay, as is given there. Some more examples for you to do. Here we'll just do example 10a. You can see that we get a over x plus b. Now remember, we said there's an invisible 1 here, okay? So now we can appreciate that if we have x being the denominator from x multiplied by 1, then here we'll appreciate that to get from x to x is just multiplied by 1, so a is multiplied by 1 gives us a, and then where we had 1 before, we have x, so I have to multiply this by x, that's by 1, so we have plus bx, okay, as is demonstrated here. So the lowest common multiple. This is something very simple, just recalling fractions and how to add, multiply and divide. Exercise for you to do there. 1.4 discusses the algebraic fractions. So we all know this is an improper fraction. What is an improper fraction? So improper fraction is when the numerator and the numerator is greater than the denominator, i.e. if a over b, then a greater than b. Okay, usually you'll see fractions as this, or you can see it as maybe 3 over 7, essentially where the bottom is always numerator, the denominator is always greater than the numerator. But the improper fraction is when the opposite is true. Okay, and then we have the mixed number, which is essentially follows. If we have 12 over 5, how many times does 5 go into 12? Well, it goes into it twice, which gives us 10. Okay, and then we have what is remaining, what is the remainder, 2. And again, this was if we insert the 5 at the bottom. So that's how we get to this particular term. And an improper algebraic fraction is one whose numerator has a degree equal to or larger than the numerator, e.g. as follows. Okay, so you can see that the has a degree equal to or larger than the denominator. We have quadratic here, linear here, cubic here, quadratic there, or both improper fractions because the numerator has a larger degree than the denominator. You can change them into a mixed number fractions either by doing long division or the remainder theorem, which leads us on to the following. If you remember in C2 we discussed the long division method, and we discussed the remainder theorem. Okay, these are two methods of dividing a cubic, factorizing a cubic, in order for us to appreciate the perhaps points of intersection with the x-axis in a graph. Okay, for us to enable us to either draw it or find out further properties of the curve. And so we went over how to carry out this operation. I'm going to just briefly talk through it. So x to the power of 3 plus x to the power of 2 minus 7 divided by x minus 3. Now if x equals 3, then we will have a remainder of 0, and if it is not, we will have something otherwise. Just by looking here we can see we have 29, so that means that in this particular situation here 3 is not equal to x, but it's just something for you to note. So we have x minus 3, and here is the cubic. We ask ourselves, how many times does x go into x3? Well, it goes into it x squared times. And then can 3 go into x3? No. So then we multiply x by x2 to give us x3, and then we multiply minus 3 by x squared to give us minus 3x squared. And so now we take away this value by this value here, so these two first terms disappear, and then here we have x squared minus 3x squared, which gives us 4x squared. And then we bring down what's left, and if you recall, we said that we cannot skip a particular power, a particular degree, so we insert this 0 multiplied by x, which is the same as 0, just to satisfy this rule if it is missing in the equation. And so we bring this down, so we have 0x. Same thing now, 4x squared. How many times does x go into that? Well, it goes into it 4x times, because if we multiply x by 4x, we get 4x squared. Does minus 3 go into 4x squared? No, it doesn't. So now we multiply x and 4x, we get 4x squared. And multiply minus 3x by 4x, we get minus 12x. And then again, we take away this with this. And so these two first terms cancel out, and we have 0x take away minus 12x, which gives us 12x. And then we bring the remaining term down, which is minus 7 here. So 12x minus 7, how many times does x go into 12? X, which is 12 times. Can minus 3 go into 12x? No, it cannot. So then we say x multiplied by 12 gives us 12x, and minus 3 multiplied by 12 gives us minus 36. We take away this from this, so we have 12x take away 12x, the two first terms disappear. Minus 7 take away minus 36, we get 29. And so does x go into 29? No, so that means we know we've come to the end. So therefore x cubed plus x squared minus 7 divided by x minus 3 equals x squared plus 4x plus 12, which is from here. Okay, and then we have the remainder 29. So we can rearrange it to be written as such. Okay, and we have these terms to identify this terminology to identify each component. So we have fx, which is the polynomial, so this is the polynomial here, the cubic equation. Then we have qx, which is the quotient. We have which is here, which is what we have here, the quadratic. We have the divisor, which is this linear value here, x minus 3. And we have the remainder, which is 29. Okay, and likewise the remainder theorem. So here in the remainder theorem, we are going to have 4 unknowns, and we try to utilize this method to eliminate certain unknowns in order for us to find each unknown individually, and then accumulating each unknown into a known, enabling us to find the answer. So you can see here again, just simply talking through it, that if we have x minus 3 here, if we let x equals 3, we will have, by putting it into the equation, we will have 9a plus 3b plus c, and you can see that you have 0 here, because if x equals 3 we'll have 0 there, plus d. Now because this is multiplied by 0, all of this disappears. Okay, all of this disappears, and then we are left with d equals 29. Now if we let x equals 0, okay, then we have 0 on the for the first two terms, minus 7, and all of these terms here will be multiplied by 0, giving us 0, except for this c here, which is not multiplied by a 0. So you can notice that if we have this next line, minus 7 equals minus 3c plus d, minus 7 equals minus 3c plus 29 from our previous calculation, and then just simple rearrangement, and then we divide by minus 3, we have c equals 12. Very simple and very easy to do. And so you figured out c and d. Now you want to find a. Compare coefficients in x cubed. So you can see now that if we compare the coefficients, we have that ax squared multiplied by x here would give us ax cubed, and is the only multiplication that would give us a cubic degree. And so comparing the coefficients, we have 1 here, so a equals 1. And then likewise comparing coefficients for x squared, we can realize that if we multiply ax squared by 3, we'll retain our quadratic, our squared. And then if we multiply bx by x, those are the only multiplications that will give us a degree of 2, or a power of 2 for our x's. And so that's how we get the minus 3a plus b. We already know what the a is from this particular comparison of coefficients, so we're left with b, our unknown, and then we rearrange and we get b equals 4. Now where we got x equals 3 was simply by noticing our divisor. X equals 0 was used so that all the terms cancel, all the unknowns are cancelled out because of the multiplication with 0 except for C, and then we use the comparison of coefficients to find A and B. So the point here is, when you look at this equation, okay, you can just by observance appreciate how to find each of the unknowns using a particular method. Now, don't be hesitant, because this is usually the technique that you will need to employ to resolve or to find the unknowns, i.e. using comparing of coefficients and multiplying by substituting by x equals 0 and x equals whatever the divisor is. These are usually the conventional terms used to find the unknowns in further questions. So it's not going to be too demanding in terms of how to what technique to use to approach solving the unknowns. And again, you have this particular example just going through the long division, and then also using the remainder theorem, which you can do in your own time. We have some exercises here further for you to do, and then we have the mixed exercises to test yourself even further. And so we have the summary of key points. So please do read through all of this. It will just recap everything we've just done, and appreciate it, because you will go on to utilize this even further in different pieces and elements, taking different elements of this and incorporating it into more deeper ideas and bigger concepts. So thank you very much for listening. We hope you enjoyed the video, and we'll see you next time. Take care and goodbye.